Hi guys, this is Zoe. I'm going to be recording a video to show you how to use your CAS calculator for quadratic equations. These are the things that I'm going to be showing you how to do, and all the ones highlighted are what's addressed in the two documents in the description box below. The type of handheld calculator that you will probably have is this. Of course, it could be like any of these ones here. They're all Ti-Nspire calculators, but the one that I have the online version of that I will be utilizing in this video is this one here. So to start with, according to my list, I'm going to show you how to plot a quadratic equation on a graph. So I'm going to open up my CAS calculator here, and we can see that obviously I've already opened up a graph page. To do that, on your home menu, you could simply click on here, but seeing as I'm already open, I could go to for or current, and it will open up what I already had. So for the people who don't know what a quadratic equation is, if it has some sort of y equals x squared in it, it's probably a quadratic equation. To plot that on a graph on your CAS calculator, we can click Tab, and we'll see that this comes up. Now, f1x is the CAS calculator's way of saying y equals. So if we remember that we don't have to change it, of course you can, but if you're sitting an exam and want to get fast and snappy results, changing it isn't really worth the time waster. So if we put in a very basic quadratic equation, which is x squared, and we click enter, we'll see that it will produce a parabola. Now, a parabola is this smiley sort of graph. It can also be the opposite way, like a hill up here. And the basic quadratic equation, x squared, produces this graph which sits right on the coordinate 0, 0. We know that by plussing or minusing a number by the basic quadratic equation, which is y equals x squared, it will change the positioning of the graph. It must, right? To check that though, we can go tab, we can go up to our first one here, which is highlighted in blue for us, and we can test that. We're going plus 2. Oh, it moves up the y-axis. So if it moves up, if we go back up to our equation, assumingly minus 2 moves it down. Cool. So on this sort of equation, there are two main things you can find. Those are the intercepts and the turning point. The window settings you can use basically mean the way that you would see your entire graph. So if we went menu, 4 or window zoom, and 1 or window settings, we can see that all these numbers are pretty intense and uneven and kind of ugly to look at. But if we know that our graph is fitting on the page pretty well, we can just adjust them so they're neater. If not, you can move your graph around using your cursor and then adjust the window settings. So we can see that this is pretty close to 10. Just make it negative 10. Ooh, that's not a negative, that's a minus. Negative 10, we're all good. We can see that this is probably more like 10 than anything else. This is more like a negative 5. And this is probably more like a 9. But just because the rest are going up by 5s, it's probably easier just to make it 10. Now that's a really clean graph. That's what the CAS calculator is good at. So this is a really good reason why to use it. Now, the first thing we can look at is intercepts. Now, intercepts is when the graph crosses the y or the x-axis. So, if this graph was to cross the x-axis, we know that the x-axis is this line, and obviously because it goes up and down, it crosses it twice. Because it then stems out in this way, it probably doesn't have a y-intercept. So we can assume that we don't have to look for it. However, it does mean that we have to find two x-intercepts. If we go to menu 6 or analyze graph, and 1 or 0, we'll get this thing coming up here. Now, it's probably going to be slightly laggier on your handheld, but the same rules apply. If you go before your graph starts and before left or right of the turning of the intercept and click down, you can then drag across until you see this 0 appear, highlighted in yellow. Click back down again and we can see the coordinate point. Now, because it's hard to read, hold your cursor over it and drag it to somewhere else where it's easier to read. Because we know we have another intercept to find, click Menu, 6 or Analyze Graph, and 1 or 0 again, and do the same thing for the other side of the graph or the other intercept. We can see that because it's a parabola and it's a very even equation, they have the same intercepts, only one's negative and one's positive. Now, according to my list, we have to find turning points. Now, there are two types of turning points that you can find, and those are minimum and maximum. This graph has a minimum turning point because it is at the bottom of the graph. A maximum turning point is on a hill-like parabola and it's a top point where it turns. If the parabola turns at the bottom, it's a minimum turning point. If the parabola turns at the top, it's a maximum turning point. Now, to find the turning point, we have to go Menu, 6 or Analyze Graph, and we have these two options, minimum or maximum. Now we have decided that this parabola has a minimum turning point, so we can click minimum and we get the same thing we did for the intercepts. Click down and this thing here will apply, and until it stops moving, there it goes, we can't click down and see our turning point coordinate. Now, the other thing I have to address is the intercepts both x and y. However, we can see that this graph doesn't have a y-intercept. However, there are some quadratic equations that can produce y-intercepts. I have a page open up already which has 3 which do have y-intercepts. These two, the red and the white, have been plus 2 and squared separately as shown here in this red equation. By squaring a number and the x by two numbers, it's going to move the graph left and right. Because this blue equation is a negative number squared, the parabola moved right, in the opposite direction. So remember, if you have an x and a negative number squared, it's going to move in the positive direction. If you have an x and a positive number squared, it's going to move in the negative direction. However, these graphs don't have very good x-intercepts. They're pretty much just here, resting on the axes. So if I go tab, I go up to these red and I just clear them up so they're not in our way anymore. I go here, just get rid of that. Enter and escape. Delete this, and we're left with our one parabola which has 2 x-intercepts, 1 y-intercept, and presumably a turning point. Because this has a x squared in it, we know that it must have a turning point. And so we can use the window zoom settings to find that turning point or find the whole graph on our page. As I showed you before, go to Menu, 4 or Window Zoom, and 1 or Window Settings to adjust. Now, we don't really need the whole -10. We can probably have more like -5. Max can probably also be 5. And Y min, we're going to need a lot more because we couldn't see the turning point. And because it was more of a frown than a hill, this parabola, we know it's going to have a minimum turning point in the negatives. So we need to make this y min a lot longer, or smaller if you like. So let's say 15 for now. And this y max can probably be 5. Now, that's good, we can see the turning point, but we can't see our other x-intercept. So we go back to window settings. We know that that is our x-axis min, and we can make it negative 10 again. Now we can see everything. Let's get this equation out of the way down the bottom here, and we can find the rest of it. So to find a x-intercept, as I showed you before, go 6, analyze graph, then 0. Here's our coordinate point. We can do that again to find the other intercept. And we know that this is a min turning point. So go 6, analyze graph, 2 or minimum turning point, bring it round. There's our coordinate point. However, to find the y-intercept, we have to go menu, trace, and trace graph. Now this will appear, so to move it, use your arrows to move it up until it says y-intercept highlighted in yellow. Click enter and it will appear. To get rid of the x, if you really don't want it, you can click escape and it will disappear and leave you with just a coordinate point. Now, I'm also going to show you how to expand, factorize, and plot domains in a quadratic form. However, I'm going to do that in the next video, just in case you only wanted sections, to make it a lot easier to do that. So if you want to watch that right now, click in the description above, and I'm sure it will take you straight to it if it works, hopefully. So for now, I'll see you guys later. Have fun doing math.